Okay, in this video I'm going to do a part 2 of special triangles, and we're going to focus on what's called the unit circle. So really in some ways this covers two different topics, special triangles and the unit circle. Okay, so let's talk about a couple things about this. This is going to be, again, a part 2. There's a part 1 if you see it on special triangles earlier. So what are we going to talk about in this video? We're going to talk about a couple things. We're going to talk about what the unit circle is. Okay, so what is a unit circle? Where does it come from? And what are we going to do with it? Okay, so you may have noticed that we've got the x and the y axis here. So here's my x-axis, here's my y-axis. And you'll notice that, again, we have a circle that's surrounding the origin. It's called a unit circle because the distance from the origin 0, 0 out to here is 1. And the distance down here is 1, and the distance up to here is 1, and the distance down here, again, is 1 or negative 1. And that's why they call it the unit circle. So imagine this. If you took like a piece of string, let's say, and then tied it right there and then moved it all the way out 1, if you took that piece of string and then just moved it all the way around, you would inscribe what's called a unit circle. So everything along the outside is a distance of 1 away from the origin. Okay? So this is an important circle because from it we get our special triangles, we get sine functions, all the trig functions, and it goes on to geometry, and we use it a lot in pre-cal and calculus and that sort of thing. So it's kind of an important circle to memorize. Now this is what we're going to do in this particular video. We're going to actually locate the different parts, the different distances away from this circle on the 30, 60, 90 triangle. Let me show you what I mean. One thing that you should know that whenever you have a circle, you have 360 degrees. Okay? So these have been divided up into 360 little pie-shaped slots, and each of these little pie shapes is what they call a degree. Okay? And if you put 360 of them in a circle, you'd have 360 degrees. When you cut it into fourths like this, each of these quadrants then becomes 90 degrees. So the distance from here to here, for example, is a 90-degree angle. And we know that because you probably recognize that. That's the symbol for perpendicular lines, right? And perpendicular lines are 90 degrees. Now what I'd like you to do on your unit circle is to actually draw not 90 degrees, but take one of the quadrants. Let's take this first one. And what we're going to do is we're going to cut this quadrant right in half. All right? Now remember that this whole distance is 1, isn't it? Because again, we said it goes from the origin all the way out to the end. So that's a distance of 1. And you'll notice that we cut our 90 degrees right in half. So now this angle is 45 degrees. What we're going to do now here is we're going to actually create a 45, 45, 90 triangle. Let me show you how we're going to do that. So we're going to go from this point out here straight down. And we're going to create another perpendicular line here. All right? Perpendicular lines. So this is my 90-degree angle. Now, what we know from triangles is that all the areas inside, all the interior angles, add up to 180 degrees. Don't we? We know that. So if one of our angles is 45 and another angle is 90 degrees, that means that this last angle is going to be 90 degrees as well. Just add those up. To prove it to yourself, just add that up. You get 135, 180 plus x. Subtract that from both sides and you get 45 degrees, again, is equal to x. So what we have here is a 45, 45, 90-degree triangle. We know that this distance is 1. we also happen to know that this distance and this distance are exactly the same. And that makes some sense, wouldn't it? Because if this is 45 degrees and this is 45 degrees, it stands to reason that both of these sides would be the exact same distance as well. All right, so we're just going to call that side A and that side A as well. And look what we get from this information. Actually, let me just backtrack just a second. What's the coordinates for this point? Well, we know along the x-axis, we know that it's 1, don't we? So we know that the coordinate there is 1, and along the y-axis, it doesn't go up at all, so it's 1, 0. When we move to this point here, again on the x and y-axis, we know that the x is 0 because it hasn't moved. X is 0. The y distance, though, is 1. So there's our next coordinate. What we're going to do in this video is that we're going to find the location of that point and then of the 30, 60, 90 degree triangles.
May I have your attention, please? Tyler Bailey, please report to Miss Taggart's classroom. Tyler Bailey to Miss Taggart's classroom, please.
So what is the location of this particular point? Well, we know that the x distance is whatever is from 0 to this point here. We know it's going to be less than 1, don't we? And we know that the y distance, crawling up the y-axis, is also going to be less than 1, because that's what the y value is. Now, how do we find that out? You can find it out by using the Pythagorean Theorem. You know that this side squared plus this side squared is going to be equal to this side squared. So let's go ahead and work that out down here, all right? I've got a squared plus a squared is equal to 1 squared. That's my first step, Pythagorean Theorem. How many a squareds do I have? Well, I've got 2a squared, so let me just put that in there. And we know that 1 squared is 1, so let's just simplify that and make it 1. Okay, now let's just solve for the a. I'm going to divide by 2. And then I'm going to take the square root of both sides. The square root of a squared is a. This actually breaks up into the square root of 1 over the square root of 2. In order to get rid of rationalize your denominator, remember you have to multiply by 1, multiply by the conjugate. And you actually end up with a is equal to the square root of 2 over the square root of 4, and the square root of 4 is just 2. Now, what did that tell us? It said that this distance now is radical 2 over 2. This distance is radical 2 over 2, which means that the x value here, again the x distance, is radical 2 over 2, and the y value, this distance, is, of course, radical 2 over 2. Okay? So now we just found this particular point halfway here, halfway down the arc, is radical 2 over 2, radical 2 over 2. That's the location. Excuse me. There we go. Radical 2 over 2 and radical 2 over 2. Okay? Now let's do the same thing with the 30, 60, 90 triangle. Let's get our circle in here again. Actually, you know what? We're not even going to do the whole circle. Let's just do the quadrant part. Okay. And then not too bad there. So now instead of going halfway through or 45 degrees, let's go, let's just move 30 degrees up off of here. Let's just go a third of the way up. So we're going to go right to here. Actually, it's actually more like right about there. So by definition, we know we're going 30 degrees here, okay? So we just moved a third of the way up the arc. And again, let's drop a perpendicular line straight down. So that makes our 90-degree angle. And you know that that would be a 60-degree angle, right? Because 30 plus 90 is 120. If it's 180 total, that means that that would have to be 60, wouldn't it? So now what we're going to try to do is, again, find the location of that point right there. Let's write in what we know. Again, we know that this is a distance of 1 because that's our hypotenuse. Now watch this. This distance we know is less than, the x value is going to be less than 1, but it's definitely over a half, right? In a 30, 60, 90 triangle, this distance is actually half of the hypotenuse. Remember that we know that from special triangles? So this is actually a half of 1, which is 1 over 2. And this distance, again, we don't know, so let's call it A. Now again, how do you might ask yourself, how do I know that's a half again, Mr. Ferrante? Well, in a 30, 60, 90 triangle, remember the way we memorize this. If this is 1, this is twice as large, so the hypotenuse is like, this particular part right here is half of what the hypotenuse is. If the hypotenuse is 1, that means that this has to be half down here, right? And again, we don't know this distance. But let's use a Pythagorean theorem to figure it out. So a squared, this side squared, plus this side squared is equal to 1 squared. So again, a squared plus b squared is equal to c squared. Now let's work this out. You're going to get a squared plus 1/2 squared is 1/4. That's just 1. Let's subtract 1/4 from both sides. You end up with 3/4. Let's take the square root of both sides. And again, remember, you can divide that into the square root of 3 over the square root of 4. See how algebra comes into here real easily? Now, we happen to know that the square root of 4 is 2. So, and radical 3 stays radical 3. So we know that the a distance now is radical 3 over 2, which means that this distance is radical 3 over 2. Okay, so what is this coordinate again? It's radical 3 over 2 along the x-axis, and it's 1/2 along the y-axis. Okay. Now, in the next video, what I'm going to show you is how we can find the sine, the cosine, and the tangent, and what that means now that we've got our unit circle identified. And let me just go ahead and show you the final version of this. Now, what have we figured out? Well, we figured out that at a 30-degree angle, we know that this is radical 3 over 2, and then 1/2 is the y value. At a 45, 45, 90 triangle, it's radical 2 over 2, radical 2 over 2. And then if we took our 30, 60, 90 and flipped it up, these would just actually be reversed, wouldn't they? We'd be halfway across the y-axis, so that'd be the half. And then the same distance along there, so it's radical 3 over 2 for that point. So now we've got these points actually memorized. And when you think about it, in the second quadrant, it would be the exact same x value, except the x would be negative, the x would be negative, the x would be negative, right? The x is negative down here. And then the y's would just stay positive because it's positive y's. And in this quadrant down here, both of them, both the x and the y's would be negative. So everything up here would be negative. And down here, it's the x values that are positive and the y values that are negative. And you can just fill in each of these points, okay? I hope that wasn't confusing. You can look at this video a couple times if it was, and then hopefully it'll sink into you. All right.